Okay, thanks for the introduction. Hello everyone, my name is Shih-Chieh, and I'm a PhD student from the University of Michigan. And thanks for coming to my talk. And today I'm going to talk, today it is my pleasure to talk about our talk, which is Edessa, a conversational in-vehicle digital assistant for advanced driver assistant features. So previous presenters show you the beauty of VR and the beauty of space. Now I'm going to bring you to another one, another interesting word, that is the beauty of the voice inside the car. So in recent years, the way that we interact with the car has been evolving significantly. For example, we can have a large touch screen to set up our navigation or increase and decrease the temperature inside the car. Furthermore, we can have a sensor built inside the car and simply just wave your hands to decide whether we want to pick up the phone call or not. And recently, there are more and more speech-based interfaces that are built inside the car. You can simply just press your button and talk to your car just like you have your own digital system to access any features that are built inside the car. The ultimate goal for all of this interface is to improve the usability and the driving experience. However, people haven't figured out which one is the best approach among all of this interface, and how to design a good interface remains an open research question. Actually, there's a need for a good interactive interface built inside the car because there are going to be much complicated in-vehicle system in the future. So a good interactive interface will help drivers to understand those features and help them to use them more efficiently and effectively. For example, one of the most emerging and promising in-vehicle systems is advanced driver assistance systems, which is also called Adasa. The goal for Edessa is to assist and share the control with drivers while driving in order to release the driver's pressure. It is also able to warn and reduce the effect of human errors. For example, one of the most common ADAS features is lane keeping system, which will warn the driver when your car is going to drift out of your lane. Another common ADAS technology that built inside our car is adaptive cruise control. When the car set up a given speed, adaptive cruise control will maintain a safe distance with the car in the front for you. There are lots of leading companies in the industry working on developing this kind of ADAS technology in order to improve the driving experience. However, the fact is that only a few drivers or people actually use this kind of state-of-the-art technology while driving. Why? We find out that there's actually a gap that prevents drivers from utilizing this kind of ADAS features. First of all, there are only around 3% of drivers actually read the user manual because they are too long or too difficult for them to understand. So they have difficulty to understand those ADAS features. On the other hand, another number shows that over 73% of drivers have not even attempted to use ADAS features. They are unsure about how to use or activate those ADAS features. As a result, there are lots of previous who are working on designing an interface to help them using this kind of features built inside the car. Visual and touch-based are one of the most common approaches that can be used inside the car. However, the result shows that the symbols on your interface might be too complicated to understand, and it might also distract driver from driving because drivers always need to focus on the road condition. They could not pay too much attention looking at your interface. So that is one downside for visual and touch-based. As a result, other previous work pivoted to investigate speech-based interface, and previous work mostly relied on constrained speech-based interface. That means that the driver have to say specific words or terms to activate or disable certain features. And that's why it usually requires higher cognitive demand for driver to use this kind of interface. And previous were mostly designed for simple or more intuitive features that are built inside the car. So the goal for this project is that we want to build an intuitive interface for to help drivers first understand ADAS features, then improve the usability and driving experience. However, building an intuitive interface for drivers that build inside the car is particularly challenging for three main reasons. First of all, it is unclear that what kind of information that drivers need. They are they're confused about the meaning of symbols or other things. And second, it requires a lower cognitive demand for drivers to interact with the interface that built inside the car because they have to focus on the road condition. Third is that if we want to access a complex systems that built inside the car, complex context of the vehicle might be involved. So these are the three main challenges that we want to address in this work. So let's look at the first one. What's the information that driver actually need? We actually look into the insight from the real customer data. So we investigate over 9,000 real customer data, which is collected from the 4 customer service division. For example, like a maintenance report or a call center, or just like simply their complaint about why this ADAS feature doesn't work for me. And we find out that among all of this question, there are 3 main interesting findings that all of this data. First of all, almost half of the questions are about the division of driving responsibility. That means that when I turn on lane keeping system, can I take my hands off from the steering wheel, or should I still keep my hands on the steering wheel? It is unclear that what's the responsibility for the vehicle and for the human. So that's the majority of the question about the driving responsibility. Secondly, around 23% of the questions are about how to activate ADAS features. Which button should I press to turn on lane keeping system? Or which button should I press to increase the gap and decrease the speed for adaptive cruise control? It is confusing for drivers to understand these kind of features. And the third one is the meaning of symbols on your dashboard. As you can imagine, like there are tons of symbols on your dashboard, and they are really confused about what do they mean if we turn on a lane keeping system and a yellow line showed up, or like a car and 3 bars showed up when I turn on adaptive cruise control. They have no idea what do they mean. So the main takeaway here is that we find out based on the real customer data, we identify 3 main factors that prevents drivers from using this kind of ADAS features, including division of driving responsibility, how to activate ADAS features, and then the meaning of symbols on the dashboard. With all of this insight in mind, we propose Edessa, which is a conversational speech-based interface particularly designed for ADAS features. We apply natural language understanding techniques so that driver can interact with Adasa with natural human language. They don't necessarily to say specific word or terms while interacting with Adasa. Then we're able to achieve real-time processing. That means that Adasa is able to provide the question to driver while they are driving so that they can figure out what their question is while driving on the highway or on the local road. We're able to handle different kinds of queries with complex vehicle context, including inquiry, system diagnosis, and command control. That means that we can just control ADAS features inside the car by simply just talk to Adasa. For example, can you help me to turn on the lane keeping system? Excellent. So this is the high-level idea about what Adasa is. And here, I'm going to show you the system overview of Adasa. So as you can see, Adasa serves as an interface between driver and the vehicle. And don't worry about like this complex diagram. I'm going to go through this diagram with a really simple example so that you can understand what's the function or like what's the purpose for each component. So first of all, driver can just press on your steering wheel and ask question like, can I turn on lane keeping system? Or like, what does adaptive cruise control do? Then we record the audio and then translate speech to a text with a speech-to-text engine. And then send this text utterance into query classifier. The purpose for query classifier is to identify what do they want to do with this specific query. We call it intent. So we train this query classifier with machine learning techniques, and then we are able to handle over 70 classes of intents with our query classifier. We collect over 4,500 training data with Amazon Mechanical Turk. So after we identify the intent of this query, we send into execution logic, which is just, if the question is just about a simple question or like FNQ, then we retrieve the answer from the knowledge base above and then goes back to driver. If that is involving a complex vehicle, like for example, the status of vehicle, or like we want to activate or deactivate the system inside the car, then we goes into another module we call the vehicle state repository. You can imagine like this repository just serves like a lookup table. It just keeps tracking the data and the signals from the vehicle, just keep grabbing the data from the vehicle and then have the table always up to date so that we can have our execution logic to get the data from this repository and make the following decision. After we make the decision with the execution logic, we generate the corresponding response and then send into a text-to-speech engine, translate into audio. speak via speaker. I'll go back to user. So this is the this is the system overview, and you can refer to the paper for more details about what each component that we made of, and then what the main bottleneck or the techniques that we apply for each component. The next step is our evaluation. So we actually implement Edessa with the end-to-end implementation on the real system, and we are able to support 2 different ADAS features, including lane keeping system and adaptive cruise control for now. Then we prototyped and then deployed Edessa onto a production vehicle, which is a 2016 Lincoln Continental. And we also integrate Edessa with a button activation, means that you can simply just press the button on your steering wheel and talk to Edessa, so that the driver can always focus on the road condition. Last, with this car, we conduct a real-world driving study with 11 miles route, including highway and local road. And we invite 15 participants to join our study. And we assign 9 different tasks for participants to interact with Edessa in relevant scenario. And note that participants are also welcome to ask any questions to Edessa, because we also want to know what's the limitation and what's the capability that we can achieve for Edessa. Then is the result. So we look at the result from 2 different perspectives. The first one is quantitative system analysis. We look into 3 main metrics. The first one is query understanding. We would like to know whether those queries could be characterized into the correct intent of class. And the result is that we are able to achieve an accuracy of 92.5%, which is really a competitive performance against modern digital assistant. The next one is the response correctness. We also want to know whether those answers provided by Edessa are correct and users are really satisfied about the answers. So during our study, after the real-world driving study, we actually asked the driver about the questions provided by the Edessa, whether they feel satisfied about the answer. And the result shows that Edessa is able to achieve around 77.6 of response correctness. And the last one is the end-to-end latency. We want to know whether we are able to achieve end-to-end process execution at real time. The result shows that at average, Edessa only takes around 1.5 seconds from driver asking question, press the button asking question, to Edessa provide the response back to driver. So it only takes around 1.5 seconds on the fly. These are the 3 main metrics that we evaluate for quantitative system analysis. On the other hand, we also look at subjective user feedback. So we actually designed and sent a 10-point scale questionnaire. And for this questionnaire, we want to evaluate the effectiveness of Edessa, but not the functionality of ADAS system itself. We want to look into if Edessa will help users to use ADAS features more and more efficiently. So we provide a questionnaire including 8 different questions in x-axis, and you can refer. We provide the complete sentence about a question in our paper. You can refer it for more details. And the y-axis shows the score from 0 to 10 regarding the system quality, information quality, and the user satisfaction. As for the system quality and information quality, we are able to achieve more above 7.4 out of 10 score, shows that participants are really satisfied about the system and the information provided by Edessa. As for user certification, question 6 and question 8 regarding like the pleasantness and whether those responses are really good for those participants. And for question 6 and question 8, we are able to achieve above 7 out of 10, which is really good. As for question 7, the score is like 3.4. You may think like it's kind of bad for this kind of questionnaire, but for this question, we ask whether drivers feel nervous about using Edessa while driving. And score 10 means that they feel really nervous. They don't want to use that at all. And for score 0 means that they don't feel nervous at all when using Edessa. And one interesting finding here is that we find out the distribution of the score are extremely different. As you can see, the standard deviation are quite large, means that some of the participants feel really nervous, whereas some of the participants feel not nervous at all. And that is one of the interesting findings in our subjective user feedback. Last, we also get some valuable insights from our user study. We conduct a post-study questionnaire interview to ask about their feelings. And there are 2 really interesting findings that I would like to share with you guys. First of all, is the response length. We find out that the different length of the response are expected in different kinds of driving scenario. For example, if participant is driving on the highway, they usually expect shorter or more precise answer from Edessa because they always want to focus on the road condition on the highway. Whereas if we are at the parking lot, participants are usually expect more comprehensive and more detailed answer because they want to know more details about how to activate ADAS features or what do lane keeping system do. So the insight here brings us that in the future, if we want to improve Edessa, the system should be able to identify the scenario, the dynamic scenario, and based on the scenario to provide different kinds of responses. Second is the query completeness. We find out that questions asked by drivers are usually incomplete and unstructured. And this is mainly due to the driver have to focus on the road condition, so they cannot come up with a complete sentence to ask Edessa. So for this one, in the future, it would be great if we want to train our query classifier to identify the purpose of driver. Then we should also collect incomplete and unstructured data for our training data so that we can have Edessa more robust and respond more correctly. So these are the two insights that we gained from our post-questionnaire interview. So to summarize our work, first of all, we identify what kind of information that drivers actually need, including division of driving responsibility, interface to activate ADAS features, and then the meaning of symbols. Then we propose Adasa, which is a conversational speech-based interface for ADAS features, and we apply natural language understanding, and we are able to achieve real-time processing. With this car, we deploy onto a production vehicle and then conduct a real-world driving study to investigate quantitative and qualitative analysis. We also get several valuable insights from our real-world driving study and our questionnaire. So this concludes my work, and thank you for your listening. I'm happy to take any question. Thanks.
That was really, really cool. I don't know if we have any questions in the room. Yeah. Wow, you're going to be there a long time, apparently. Okay. Also, please introduce yourselves and your affiliations.
Sure. Hi, I'm Sean Mooney from CodeThink. Have you thought about the safety implications of this?
Can you say that again?
Have you thought about the safety implications?
Safety implication?
Yeah.
So during our driving study, the first priority that we ask participants to look into that they have to make sure that they have the full control of the car, and then they could not sacrifice the safety about like if they want to interact with the Adasa. So that's one thing. But as for like accessing the internal vehicle signals for safety reason, we actually make sure that we won't access the signal for like pedal speed or like the steering wheel in order to make sure the study is safety. Yeah.
Okay, but if you're doing things like cruise control changing, like the speed and that, then you must be able to change the cruise control. So surely that has safety implications.
So that's why we focus on adaptive cruise control and lane keeping system. So for lane keeping system, the car is always set in the same lane. It won't change to another lane. So that's the one of the reasons that we focus on these two common and simple features inside car. We didn't move into other like cruise control to other lanes. That's a really good question.
Okay, thank you.
Thank you.
Andrew from Google. I have a question regarding, do you have any insights on when and what context that users are accessing these kind of information? Because for voice user interface, the challenge is always what to ask, when to provide the right information. So I'm interested in that.
Yeah, so actually, we also have question, like we also have the class for drivers to ask question like when to use this kind of features, and then like when should I use and what to use and how to use. As for your question, you are asking about like what's the behavior what driver usually asks more questions. In our study, we find out that they're still kind of feel nervous about Edessa because it's kind of prototype, so they ask less question on the highway, and they feel more comfortable at a parking lot to know more details about ADAS features. So there are less questions during the highway, but we still assign some questions for them to ask.
Do you have kind of like observations regarding is like certain signal turn on their visual interface and then user ask questions or something, those kind of observations?
Yeah, so actually for lane keeping system, mostly are fine. The symbols are mostly understandable. But for adaptive cruise control, there are lots of signals happening. Like there are symbols showing up on your dashboard. So when they are interacting with Edessa for adaptive cruise control, they are totally have no idea about the symbols on the, like for a car, or like 3 bars, or like the lines. So they ask a lot of caution about the symbols on the dashboard.
Thank you.
Thanks.
Okay.
Shamsi Iqbal, Microsoft Research. Very cool.
Thanks.
Doing driving studies on the road is very difficult, so we appreciate this work. Thanks. So I have a follow-up question from the previous one, and it's extending a little bit of that question. Okay. And so do you have sense of when, during driving, drivers would ask certain types of questions? You mentioned highway versus parking lot, but even on the highway, are there certain parts where drivers would pick as opportune moments to ask questions versus they wouldn't ask questions if there are a lot of cars on the road, for example?
So you're asking like for a specific period they would like to interact with Adasa. Mm-hmm. So for a highway, like when they are going to ramp up to the highway and then ramp off the highway, they usually like just want to control the entire car. They don't want to like give the control with ADAS features, but not for Edessa. With interacting with Edessa, they usually like to ask questions while there are less cars than there are a lot of cars that are congested on the highway. That is one of observation that we find out. So that's why there are some numbers that actually depends on the traffic condition. If there are like a lot of cars, they usually ask less questions. And if there are lots of cars, there are less cars there, they usually ask more questions on highway. And
do you see any impact on driving performance?
As for the performance, so because this is kind of prototype, so first priority is that we want to make sure everyone in the car is safe. So if they don't feel comfortable with for Edessa to access the internal vehicle, we should ask them to press the pedal and then get the control back. So we didn't actually look into how do that affect like the driving time or like the speed in terms of using Edessa. Yes.
Thank you.
Thanks.
Okay, Bastian Pfleging, LMU Munich. Nice talk, and as I just can agree, so like doing real world driving studies is a challenging thing, so good that you do such stuff. One question regarding like the interaction, so you looked into speech interaction. Typically in the car, I think if people don't know what to do, they also might point at things, do things. So did you think about multimodal input?
Multiple input?
Multimodal input, so like pointing in addition to just speech interaction.
Oh, you mean like with different, with multiple inputs for the interface?
Yes.
That's a good question. Actually, we think about, so the first idea comes into our mind to design this one because that we don't want to, we want to keep the driver's eyes on the road condition. Mm-hmm. So they can just simply talk to whatever they want. So we didn't consider about like the visual or the touch interface because like they have to distract something like there. But other things like, yeah, pretty much we didn't consider others input for now, but maybe in the future, yeah.
Yeah, and one follow-up question, I think.
Sure.
All these systems which we have in a car, so if you, I don't know, like living in Munich, if you rent, let's say, a 7 Series BMW, which is fully equipped with all these systems, it's extremely difficult, I think, for a non-expert to actually use that car because there's so many interfaces, so many features.
Exactly.
Do you have any idea about a strategy how to introduce this one by one after another to the people?
That's a really good question. So actually, in the future, like we want to extend a more ADAS feature for sure, and then more static features like for inside the car. As for the autonomous driving, like more level 5 or level 4, level 5 features, I think the first thing that we want to make sure that is like, even though without those interfaces, it should work normally, like functionally, even without those interfaces. And then we apply the interface for that. I think that's our current thought for now.
Okay, thanks.
Thank you.